This is Colin Dixon with nScreen Media, and this is nScreenNoise. Today is July 16th, 2015, and I'm talking with Eric Achman, who is Executive Chairman of vNova. And as my listeners will know, vNova is a new video compression company with completely new techniques. But Eric, you have a very interesting demo of the technology that you want to tell us about. So tell us about what you were doing with Airbus.
Great. Well, first of all, Colin, it's great to see you. And in fact, the demo was an evaluation for practical applications in aerospace. We, in fact, partook in the first crossing of the English Channel from Lydd near Dover to Calais by an all-electric aircraft known as the Airbus Group EFAN technology demonstrator. As part of that program, we were fortunate enough to have our logo on the airplane, and our contribution was providing video telemetry to and from the aircraft, which involved pumping HD video, so 720p 25 video, over the publicly accessible mobile networks, 3G, to the aircraft and chase aircraft during the flight and during testing.
So you were doing this over standard 3G networks?
That's correct. In fact, it's even more exciting than that, because one has to consider that in Lydd, you're in rural England. So when we talk about 3G networks, it's practical networks. So you don't always have 5 bars. And then you take off in a search and rescue helicopter or other aircraft, and you climb to 1,500 feet. You're in international airspace over the channel, multiple networks, and then flying to a new country and picking up the networks there. And so it's an interesting thing, sending HD video over local networks to a moving aircraft at the edge of 3G range at 1,500 feet, flying at high speed.
So now typically what we'll be looking at with a 720p video is something in the range of, I don't know, something around 5 megabits per second, maybe 4 megabits per second at best. So how much was Perseus able to compress that beyond that level?
We were streaming very good quality at around 300 kilobits per second.
300?
Correct.
Kilobits.
100 kilobits or 0.3 megabits.
So I guess that explains how you were able to get it over a 3G network. And what was the connectivity like across the channel? Was it well connected all the way, or did you lose 3G coverage along the way?
No, we were not able to maintain connectivity over the channel, because at points you do lose connectivity. Keeping in mind also that when you're flying at altitude, you do not have access to mobile networks at all times. So our connectivity was limited to essentially take off and climb out until we were just off the channel, and then, of course, approach, landing, and taxi. So where there was a network, we were able to acquire it and stream. When you lose the network, it doesn't matter what bit rate you have. Zero network equals zero.
You've got no signal, of course.
Exactly.
So what exactly was the content of the video that you were streaming?
We streamed in both directions. So we streamed up to simulate to the aircraft complex content, which was a selection of fast-moving scenes and panning shots, basically Airbus Group demo material in high quality. And we sent that up to various aircraft to demonstrate the fact that you could, first of all, get large amounts of rich data to the aircraft, but you could even imagine in this technology demonstrator that your flight instructor would be on the ground speaking to you in the aircraft on video. Then in the other direction, we had camera ships, camera helicopters, flying in formation, filming the event in the air, spectacular footage which you can see on the Airbus site. And we streamed that video to, for example, our offices in London, Paddington, and then distributed over 3G to people in London who had devices equipped with Perseus and could watch it in real time.
And I'll of course include a link to those videos in the piece that I post when I post this piece later on. But that's not the only thing you've been doing with Airbus, right? You had another demonstration with virtual reality. Tell us about that.
Absolutely. So we have a long history, members of the team in aerospace, and also a long relationship with Airbus. And one of the things that they asked us to do was to apply Perseus to the Airbus Group 3D virtual reality experience, which was one of the main demos that was demonstrated inside the Airbus pavilion at the Paris Air Show a few weeks ago. The Paris Air Show, as you know, is the world's oldest aerospace exhibition and one of the largest trade shows in the world, trading around 200 billion or more typically in a good year. So people who came to the Airbus pavilion, including presidents and prime ministers and a lot of senior people in press, were able to put on an Oculus Rift headset running Samsung. And as they put the headset on, they were able to look into the sky, see the collection of Airbus aircraft and products, point to an aircraft with crosshairs, have the ability to draw information on that aircraft or on that product, and then enter the product in the case of, for example, a commercial airliner, where you're then in the cabin in virtual reality, panning around and seeing what it would be like if you were flying in an Airbus.
And so that interesting question there is, what sort of compression were you able to get on virtual reality video?
So we currently are not publishing that information, Colin. I'll be able to give you some more detail in a short period of time.
Oh, okay. But needless to say, it was some. I would imagine somewhere in the same region as we're seeing with the HD.
Absolutely. I can say that the performance that we gave in virtual reality was consistent with the performance that we've given using Perseus for other applications.
And just for those watching this who are not familiar with Perseus, why don't you just give us a quick overview of what Perseus is and does?
Absolutely. The company, of course, we know is Vinova. The product is Perseus. Perseus is software encoding technology that can be used to, what we say, turbocharge the existing infrastructure and workflows, also working on existing and commercial off-the-shelf hardware. Perseus has benefits in the fact that it can provide superior compression at all levels of quality with the same or lower latency. So, a perfect example being the ability to provide a UHD quality content or video over existing HD networks and infrastructure, as we demonstrated with Airbus HD video over what we call SD bandwidth, which, for example, is the 3G mobile infrastructure that we spoke about, and SD quality video at sub-audio bit rates. We've demonstrated a number of times our ability to give SD video at bit rates below what would be typical of music streaming that people are used to using from providers like Spotify or iTunes.
And in the Airbus example, what was the latency? Was it 20 seconds behind the actual events?
No, in fact, Perseus is extremely fast. So typically, for example, HLS puts the latency into the system. There was no perceivable latency from Perseus itself, which generally has a latency of roughly 3 frames or so.
Oh, really? So that's so it really is for real-time use. Can be used very well for real-time use.
Absolutely. It was quite funny because a number of the journalists at the event, because of course you couldn't see the aircraft in crossing the channel unless you were watching video footage, and so a number of the journalists and even some of the PR people were turning to our technical people to watch the event on the phones.
Very good. And does it take does it take a lot of processing power for Perseus to do what it does? Do I need a huge bank of computers running Perseus to keep up?
Absolutely not. Perseus is incredibly efficient, and testing with global mobile network operators have demonstrated that on typical devices like Android devices, for example, Perseus implemented as a software is using anywhere from 15 to 25% less processing power than H.264 implemented in the hardware.
Wow.
And one of the reasons why we're able to do that is because Perseus is natively massively parallel, meaning that it's able to use the inherent native acceleration in the massive parallel architecture of today's common chips.
Fantastic. Well, this sounds like it was a great demo, and I'll certainly include those links, as I said, so that people can actually see the plane itself and some of the performance. I think you have some video actually of you holding a cell phone with the video playing, so they can actually see it's real time. So this is great stuff, Eric. Congratulations.
Well, thanks so much. Great to speak with you as ever.
And this has been Colin Dixon with nScreenNoise. We'll see you again next time.